Hello students, we are going to see today a problem over plane strain condition. This is your second problem or assignment number 6. Previously we have seen plane stress condition problem, that is of spanner, where we have find out the maximum deflection of the spanner when it's subjected to plane stress condition. So in this problem, a long cylinder is subjected to uniform internal pressure, that is 10 kilonewton under plane strain condition, and Young's modulus is 2.1 into 10 raised to 7 Newton per centimeter square. 1 upon m, that is Poisson's ratio, mu equal to 0.3, and you have to calculate the maximum deflection in the pressure vessel. The outer diameter of this pressure vessel is 20 centimeter and inner diameter is 10 centimeter, which is subjected to the constant pressure. So in this problem, before solving in the answers, is first of all we have to divide this into one part, that is in 90 degree. We have to use this part only, instead of drawing the entire this whole pressure vessel. We have to just use this portion, that is 90 degree part of this pressure vessels. This is why, because while giving the boundary condition and to this pressure vessel, if we draw all this into the 360 part in this way, if we draw it in this way, then we can give the pressure over this internal surface. Okay, we can easily give the boundary condition, that is pressure over this internal surface, but we can't give the displacement because all the boundaries are closed if we use this all 360 degree model. Okay, if we use 90 degree model or 180 degree model in this way, just a minute, yes, in this way, then we can apply displacement over this surface, and then we can use the pressure over this internal surface. So that's why our boundary condition will be fulfilled. So that's why we have to draw only 90 or 90 degree or 1/4 of this entire pressure vessel in the ANSYS APTL. So let's begin with the problem. So first of all, select the preferences, that is structural, select OK, then go to the preprocessor, element type, select the element type, just a minute, element type, that is solid element. In solid element, select 8 node 183, because if we use this code 4 node 182, it can solve the problem, but it shows one error, that is instead of using this 4 node, you can use 8 node or 12 node or 20 node element for solid. So that's why I'm using 8 node 183. So in this we have to select the elemental behavior, that is a plane strain condition problem. You select OK, close it, then go to material properties, and you have to define the properties of our material, that is modulus of elasticity. So in isotropic, given is 2.1 into 10 raised to 7, so 2.1 E7, and 0.3 is a Poisson's ratio as it is given in the problem. Then close this window, then go to modeling, in which we have to create the model. So previously I have explained you that we have to create only 1/4 of the pressure vessel. So go to circle, then you can use this annulus or bidimension, that will be more easier. So bending angle should be 90 degree, because I am using to draw only 1/4 of the pressure vessel. Okay, then outer diameter is 20 centimeter and inner diameter is radius will be 10, because the diameter is 20, and inner diameter it will be 5. Okay, diameter is 10 centimeter, so I'm using unit centimeter. Use only one, and or you can use here 100 and 50. But so in this way you have created the 1/4 of your pressure vessel model. Now you have to mesh this model. So go to meshing. So in that you can go to this directly mesh tool, or you can go by manually by using this manual size control and give that values and all. So I'm using here mesh tool command. So in this smart size, and I will move this to fine and select this mesh into, because we have created area, so we are using area. In that free meshing, mesh and select that area we are going to mesh it. So select OK. In this way it is meshed. Now we have to give the boundary condition to your problem. So as explained, we have to give applied structural in that displacement over this line and this line. Okay, so go to on symmetry. Okay, symmetry online symmetry boundary condition. So this end and this end, that will be not possible if I drawn on all 360 this pressure vessel. It can be not be possible because this thickness will sustain the pressure. So we have to use this as a symmetric displacement. Okay, so after giving this, go to pressure. So in this, if I directly use on line, it will act linearly. So we have to change this work plane to uh, global Cartesian to global cylindrical. Okay, then go to on line and select this inner diameter of the pressure vessel and select OK. And now we have to give the pressure value. Given is 1000 10 kilonewtons, so 1000 newton per centimeter square, and select OK. Okay, in this way the pressure is applied over the surface and surface. Now go to solution and solve current ls in this way. So you can see this, the inner surface is subjected to uniform pressure, and these ends are subjected to the symmetricity displacement. Okay, now after solving this you have to find out the results. So as this is a student version, so we can't plot the results for stress and strain, but I will teach you the command where we have to click. If you are using another version of ANSYS, it can shows the result for this. So as the package is not included in the student version, so it shows an error. So go to contour plot, DF solution. In this displacement vector sum, select OK. So in this way, the maximum is this area is subjected to the maximum deflection. And now if we want to least result nodal solution, go to DF solution, displacement vector sum. So in this way, the UZ is not subject to, that is the Z direction is not subjected to any deflection. Only the X and Y coordinates will subjected to deflections. Okay, now I will teach you the how to plot the uh, stresses. If we using another type of another mod ANSYS version, then you can find out this stress. In this stress you have to go for this one Mises stress. If you select this one Mises stress, it will shows you the stresses value. So you can see this request yes data is not available, so there is no inclusion of the package, so it's not showing it. And for the plane strain, again go to contour plot, nodal solution, and in this elastic strain I have to use X and Y. x and y. So you can, again it shows, because it doesn't include the package of full package of ANSYS, so it's showing an error. So this is your end result. So for, again, for this you can see in this problem, in this way you have to plot the uh, your result. If you want to plot this result, to go to plot control, in that style, then symmetric expansion, and use this first cyclic symmetry, and use 1/4 not, this is not, plot control, style and shape, symmetry expansion, cyclic expansion. Which is showing error, I think so. Style, shape, cyclic, periodic, reflect xy, not showing. Just a minute. So in this way, your entire pressure vessels can be analyzed. Okay, I am drawn only this part, but the ANSYS uses the symmetricity, and I plotted the another 4 quadrants also. So in this way, you have to take the snapshot of this, going to the right meta file, invert white and black, and use this you. I'm seeing this, it is in picture or music, where it is gone. I will save again, go to plot control, right meta file, invert white and black, and it is going in the documents, going in document. So I go into document, document, and that you. Okay, so in this way you have to plot the, again resize it as you can, or you can use select and just use this up. Okay, only this, take the print of this, and then the list results. In the list result, nodal solution displacement vector, you have to use only this portion, only you use this portion. It will shows you the maximum deflection values. Okay, so use this only. In this way, this completes your second problem for the assignment number 6. So take a print of it or save it. After saving this, when the college get resumed, you will check it up. Okay, so stay tuned for the third problem, that is of the assignment number 6, that is on an axis symmetric. So stay tuned for that. I will upload it, I think with this video only I will upload it, the third problem, and that will complete your assignment number 6. So thank you.